Good day, everyone. This is Chris back again with the Ancient Scholar, and this is going to be video number 3 in a series of videos covering the introduction to dosage calculations for respiratory therapists. This is a homework assignment that is one of the the second homework assignment actually that my students from the respiratory therapy class, the fall semester of 2012, will have at this point turned in already. Okay, so let's pick up where we left off. Number 9 here. Number 9 says after administering the second dose. Okay, so I've administered 2 doses of nitroglycerin via sublingual tablet. Patient reports feeling no chest pain. Well, is this relevant? The no chest pain, is that relevant to the question? No. And like I said, sometimes you'll have a question where it gives you more information than you need. So again, be mindful on what is this question really asking. Is it asking anything about the chest pain, or is it asking you just to do something? And in this case, this is just ultimately it's asking me to do something. So really look at these questions and kind of think, okay, what is this really asking? Because you may have some extraneous information thrown in. How many total micrograms of nitroglycerin have been administered at this time? Okay, so what it's asking is, I want to know the total number of micrograms of nitroglycerin that have been given to my patient. Well, let's go ahead and figure out how many milligrams the patient has received. So if the patient's received a total of 2 0.4 milligram doses, well, that's just 0.8 milligrams, right? So my patient has received 0.8 milligrams, and now all I need to do is I just need to convert milligrams to micrograms. So if you remember the conversion formula, the conversion factor is 1,000 micrograms per every 1 milligram equals X micrograms, that's what I need to figure out, and 0.8 milligrams. Okay, so I'll cross multiply that, and X equals 0.8 times 1,000 is 800 micrograms. All right, so my patient has received 800 micrograms, or 0.8 milligrams, and that should make sense because 1 milligram would be 1,000 micrograms, so 0.8 is pretty close to 1, so it makes sense that it should be about 800, or should be 800 micrograms. Okay, let's see here. Question 10. I receive an order to administer 0.5 milligrams of epinephrine 1 to 10,000 IM. How many milliliters will you draw up? So this is the first thing I need to do with any concentration is I need to figure out what 1 to 1,000 is. You remember, the 1 in this kind of setup is always grams, a colon followed by 1,000, 100, 10,000, whatever. That's always milliliters. So this is 1 gram in 1,000 milliliters. But the question is asking... the question has my dose in milligrams, so I need to convert that to 1,000 milligrams in 1,000 milliliters, right? 1,000 milligrams is a gram. All the zeros cancel out, and that's 1 milligram per 1 milliliter. Okay, so that's my concentration. So now that I know what my concentration is, I've simplified it as much as I can in milligrams, I can go ahead and solve the problem with the have want. So let's do that real quick. Have want, and I have 1 milligram in 1 milliliter. Okay. And I want to give 0.5 milligrams, again, keeping the same units on top and bottom, and I need to figure out how many milliliters that is. 1 times X is just X, and then 1 times 0.5 is 0.5, so X equals 0.5 milliliters, and that makes sense because 1 to 1,000 is a 1-to-1, 1 milligram per milliliter. So if I wanted to give 0.5 milligrams, well then that makes sense that I could give 0.5 milliliters. Okay, so let's take a look here at the next one. Okay, so my patient must receive 10 milliequivalents of potassium IV over an hour. You have a 1,000 milliliter bag with 20 milliequivalents of potassium mixed in it. How many milliliters of the bag must be administered? Okay, let's draw a picture to simplify this a little bit. So what this is saying is, here's my IV bag, okay, and I have 1,000 milliliters in that IV bag, and dissolved in this I have 20 milliequivalents of potassium. Okay, so dissolved in this bag, in this 1,000 milliliters, I have 20 milliequivalents. Okay, and I need to figure out how many milliliters will equal 10 milliequivalents, because that's what I need to administer to the patient. There are several ways of going about this, and let's just maybe go about it in a way that'll give us some sort of conversion factor. So if I have 20 milliequivalents in 1,000 milliliters, I can kind of break that down to 2 milliequivalents per 100 milliliters. Okay. So I could go 2 MEQ per 100, okay, and I could set up just a quick have want, 2 milliequivalents in 100, and I want to give 10 milliequivalents in X milliliters, okay. 2 times X is just 2X equals 100 times 10. Is just adding the 0, so it's 1,000. Divide both sides by 2. 1,000 divided by 2x equals 500 milliliters. And hopefully that makes sense, because if I have 20 milliequivalents dissolved in 1,000, well, half of 1,000 is 500, and obviously that would be 10 milliequivalents. So that does make sense there. Okay, let's move on here. This isn't a math, but this is just kind of a review from the first lecture. What are the 4 phases of pharmacokinetics? And the 4 phases include absorption, distribution, biotransformation, or metabolism. Those both mean the same thing. And then elimination. The primary organ of metabolism is the liver, and metabolism includes catabolism and anabolism. And I can either have active or inactive metabolites being produced. And then the major organ of elimination will be the kidneys, but you also have elimination through the alimentary canal or the gastrointestinal system. You also have elimination through mucous membranes, through the skin, really. And then elimination through the lungs can occur as well, but primarily the kidneys. And then compare and contrast pharmacokinetics and pharmacodynamics. And remember I said pharmacokinetics is what the body does to a drug, right? As a drug moves through the body, what does the body do to it? How does the drug change? How does it move and change? And then pharmacodynamics is what the drug does to the body. So the pharmacodynamics is how a drug actually works, how it acts upon the body, or in some cases how the active metabolites of a medication act upon the body. Okay, and then last but not least, question 14, and this is a half-life question. A patient receives 100 milligrams of medication X, PO, orally. It has a bioavailability of 0.25 when given orally, and a T1/2 or half-life of 2 hours. How many milligrams are left within the patient after 6 hours? Well, the first thing we need to do with any kind of bioavailability is figure out how much of this 100 milligrams has actually made it into the body. And remember, 0.25 is 25%. Okay, it's another way of expressing that. So really all I do is I multiply the bioavailability by how much I've given the patient. In this case, it's 100 milligrams multiplied by 0.25, and that gives me 25 milligrams. So only 25 milligrams actually makes it into the patient. Okay, that's whatever this medication is obviously has a lower bioavailability given orally, and that should come as no surprise. Most medications do have a lower bioavailability, but be that as it may, we're starting with 25 milligrams. So what I'm going to say is that 25 milligrams is going to be my time 0, okay? And then it's going to, after 6 hours. Well, let's do this. Let's just do a little experiment and experiment our way to the answer. My half-life is 2 hours, so let's just figure out how much is left after one half-life, okay? So let's do 1 half, okay? That's 2 hours, so I'll write 2 hours here. And that's going to be half, or 12.5 milligrams. Okay, fair enough. Well, let's go to 2 half-lives, okay? So that's going to be 4 hours. So 2, that's supposed to be a 2t 1/2, 2 half-lives. Well, that's just going to be half of that, right? 6.25. And let's just go ahead and extend it another half-life. Well, that would be 6 hours, right? Another 2 hours. So that's 3t 1/2, 3 half-lives. And then it's just going to be half of that, 3.125 milligrams or thereabouts. Well, now I've arrived at my answer because here I'm at 6 hours, and that's what it's asking after 6 hours. And remember, I said that I would never give you anything in between. I would always stay at a whole half-life, because to find any concentration between is going to require the use of a differential equation, which is not a requisite for this level of pharmacology. So I was always going to do whole half-lives, which makes it easy. So there we are, 3.125 milligrams are left after 6 hours, because 6 hours is 3 half-lives. Okay, guys, that is the review for this homework assignment. I hope that you found this helpful, and I hope this helped solidify some of the concepts. And if you had questions, I hope this helped. Please don't forget that you can always contact me if you need additional help tutoring. We also have a respiratory therapy tutor who is available. I know some of you have already started using her. And we also have dosage calculations tutors in the Student Success Center. So don't be afraid to use all of these resources. You have them available. They're getting paid. We are all getting paid for your education. As a student, it should be your job to use us and abuse us until you feel a warm fuzzy about the material. Okay, guys, as always, thanks for hanging in there, and we'll see you in the next video.